this video today, we are going to be talking about Unit 13, which is on second-order linear differential equations. If you recall, we have already talked about the homogeneous case, and we have started talking about the non-homogeneous case, but in this video, we are going to consider a more complex non-homogeneous case. So to illustrate this more complex case, let's consider the non-homogeneous differential equation that's given here. D squared x over dt squared plus 25x equals 10 cosine of 5t. So suppose we wish to find a particular solution, and our initial guess might be something of the form a cosine 5t plus b sine of 5t. But this problem says that that guess is doomed to fail, and we need to explain why. So the hint says to look back at number 10. Well, I'm not going to go back and scroll to the solution for number 10, but what we did in number 10 was we solved the homogeneous case, which was d squared x over dt squared plus 25x equals 0. So this was number 10. We ended up getting some complex roots for this, and we got that our solution, our general solution, was c1 cosine of 5t plus c2 sine of 5t. And it's possible that I'm mixing up the order there, that it was the sine of 5t first and the cosine of 5t second, but it doesn't matter because these are arbitrary constants. So this is what our general solution looked like. And notice, if we compare the general solution to this particular solution, they are almost identical. The only difference is we have undetermined coefficients a and b instead of these general integration constants c1 and c2. But the variable parts of these functions, the cosine 5t and the sine of 5t, are exactly the same. Now we know that this is a general solution to the homogeneous equation, which means that if we differentiate it and substitute it into the left side of the differential equation, we will get that it equals 0. So if we tried to take this function as the form of our particular solution and plugged it in here, we would just end up getting 0. We wouldn't be left with anything. We wouldn't be able to equate the coefficients. So this method of undetermined coefficients is not going to work with this. So a very brief explanation, xp of t equaling a cosine of 5t plus b sine of 5t is the same as the homogeneous solution so it will disappear, and by that I mean go to 0, if we substitute it into the left side of the differential equation, which I'm just going to abbreviate as DE here. So that means that we won't be able to pick this as a particular solution. So that's definitely a little bit more complex than what we've seen before. So let's continue on. Part B. Nevertheless, explain why your particular solution must have terms that look like cosine 5t and sine 5t. Well, the reason for that is because the right-hand side involves cosine of 5t. The right-hand side involves cosine of 5t and derivatives of both sine and cosine give cosine functions. So if we're thinking about taking a function and substituting it into the left side of the differential equation in order to get something that looks like the right-hand side, then it has to be something involving cosine and sine. But it's not the simplest thing that we can think of involving cosine and sine. So there must be something a little bit different, but still involving cosine and sine, that will work. So part C, for an unknown differentiable function f of t, write down the first and second derivatives of t times f of t, and then after we've done that, what do we notice? So what we need to do is take the derivative with respect to t of t times f of t, and notice this says that f of t is a differentiable function, so that just means that f prime of t exists. So if we're differentiating this product of functions, we can just write the derivative of f as f prime. So like I said, this is a product of functions, so we're going to have to use the product rule. Derivative of the first, which is t with respect to t, is going to be a 1 times the second f of t plus this, the first t times the derivative of the second, so f prime of t. So this is f of t plus t times f prime of t. And this is the first derivative here, which is one thing the problem asks us to do. But the problem also asks us to find the second derivative. So we need to differentiate again, which means we're going to find the derivative with respect to t of what we just found, f of t plus t f prime of t plus, there we go. So derivative of f of t is going to give us f prime of t plus, we're going to have to use the product rule again. Derivative of the first with respect to t is 1. So I'm not even going to write that there. Plus derivative of, times the second, so that's f prime of t. Then plus the first t times the derivative of the second, so that's going to be f double prime of t. So we have two like terms here. We can combine those, so we get 2 times f prime of t plus t f double prime of t. Now, there are, of course, a lot of things that you could notice with this, but since I already know the connection that I want to make with this problem, I'm going to point out here that the derivative of t times f of t and the second derivative involves the original function, the derivative of f, and the second derivative of f. So both derivatives involve f of t, f prime of t, and f double prime of t. And the reason why that's important here is because, think back to our answer to part B, we are wanting to choose something for a particular solution so that the derivatives involve what's on the right-hand side. Well, if we choose t times a function that's on the right-hand side, the derivatives will involve the function on the right-hand side, its derivative, and its second derivative. So if we chose t times cosine or t times sine, we would still end up with something involving sine and cosine. So that leads us to maybe choosing a times t times the cosine of 5t, because we have cosine, we have cosine of 5t on the right-hand side. But part D says, explain why a guess of at cosine of 5t is insufficient. Well, the reason here is exactly the same as what we saw before with the simple case. You can't just choose cosine. You would have to choose cosine and sine in order for it to all work out. So we need to choose cosine of 5t and sine of 5t. And I think I will break here. We will pick up with this next part in the next video.